Welcome back guys, and I have finally caught up with the modern times and bought myself a lithium battery for the Land Cruiser 200 series. So in today's episode we're going to talk about everything lithium. We're going to talk about why I bought a lithium battery, the advantages and disadvantages of a lithium battery, the cost analysis, issues regarding heat concerns and battery longevity. So guys, it's going to be a great episode. Make sure your devices are charged and let's get straight into it. So I've done it. I finally went out and bought a lithium battery to replace the AGM battery in the Land Cruiser 200 series. Now I've been using AGM batteries and calcium type batteries for the last 10 years in my four-wheel drives, and to be honest, they've performed okay. There is no doubt that the AGM batteries have outlived and outperformed the calcium type, but the system's been adequate overall up until recently when my power demands have increased a little. So what have I done? I've gone out and bought an iTechWorld lithium 120x 120 amp hour deep cycle battery. Now there are plenty of options, brands, manufacturers and types of lithium batteries out in the market, but I chose this particular battery for a specific reason, which I'm sure will become evident throughout the video today, but mainly because of its price and more specifically the value for money with this particular unit. Now I should mention that I've gone out and purchased this battery with my own money, and I have not spoken to iTechWorld about doing this review, and they're not sponsoring this video in any way. So without further ado, let's get the AGM battery out of the Land Cruiser and talk about both of them side by side and some of the differences between them. So we have this AGM out of the Cruiser now and on the table, and I want to take this time to compare these batteries side by side to talk about some of the differences and the similarities between both of these units. So starting with the fact that both of these batteries here are fully sealed units. And in fact, the lithium i20X has recently obtained an IP67 waterproof rating, which means that technically you could submerge this battery in a meter of water for half an hour if that's something that you really want to do. But overall, these batteries are both safe to be mounted in most locations and orientations in your four-wheel drive or 12-volt setup, whether that be a trailer or otherwise. Now both of these batteries have very different chemical makeups. However, I know there are some concerns held about the safety and the reliability of lithium units, particularly when exposed to heat and suffering from a condition sometimes referred to as thermal runaway, which causes explosions and sometimes injury or damage to property. Now I want to mention that this battery here is a lithium ion phosphate battery, sometimes referred to as a LiFePO4, which doesn't suffer from those thermal runaway problems or other issues associated with batteries that are made up from lithium ion or lithium polymer. So both of these batteries here are very safe and very stable to use in your 12-volt setup. Now, although these batteries do share some similarities, there are some major differences between how these batteries work and why lithium is becoming so popular, particularly in the overlanding and four-wheel driving market. So let's get into some of these. So let's start with what is probably going to be the most well-known difference between these two batteries, and that is going to be weight. I think it's fair to say that most people understand that a lithium battery is going to be significantly lighter than an AGM or a conventional deep cycle battery, and there is no exception here. The specs from Full River for this battery here state that this battery is going to weigh 30.2 kilos, and moving that onto our scales, we can see that it comes in at 30.9 kilos. Moving on to the iTech 120X, although there is some contradictory information in regards to some of the manuals between 10 and 12 kilos in weight, moving on to our scales today, we can see here we're pulling in at 10 kilos. That is a huge weight saving of 20 kilos and something that's going to be very helpful, particularly for my case where I've got a Cruiser that is already very heavy. Removing 20 kilos from over the front axle is going to go a long way for assisting my touring build. The next big difference between these two batteries is the way in which they discharge, and there's a reason as to why sometimes lithium is referred to as having more power. So let's dive into this. The first reason is the voltage discharge profiles of these batteries. An AGM battery, for example, is said to be at full state of charge at around 13 volt or 12.9 volt when resting. Now, as we draw power or use power from this AGM battery, we're going to see that voltage decrease, and a battery is said to be at a 50% rate when at 12 volt. As the battery starts to get lower than this, our electrical appliances that are plugged into our 12-volt system will start to struggle and begin to use that power inefficiently. Further, there are some modern day sensitive appliances that just won't pick up that power at all, and an AGM battery is said to be flat when it reaches about 10 to 10.5 volt. If you have brought a battery down to this level, there's likelihood you've caused some permanent damage to the battery, and this is going to significantly shorten its cycle life. This is vastly different from how the lithium battery is going to react when power is drawn from it. At a full state of charge, the lithium battery is going to hold about 13.5 volt. And as we draw the power from it, the voltage is still going to remain at a much higher level. It will still decrease, but by nowhere near as much as the AGM counterpart. So we can see here from iTechWorld's discharge chart, we see that we're expecting the voltage to drop down to the high to mid 12 volts, even when it's down to as low as 20% before shutting down. So in a realistic scenario, an AGM battery can only really utilize about 50% of its amp hours rating. So this battery here is rated to 105 amp hours, and driving it down to 12 volts at its 50% mark is going to give us about 50 to 55 amps of usable power from this battery before it requires a recharge. Compare that to the lithium battery here, where we can see it holds that voltage nice and high all the way down to 20%, which means that we can use up to 96 available amp hours, given that this battery here is a 120 amp hour unit. There's another big advantage to the way in which both of these batteries discharge, and it's referred to as a C rating, which measures the efficiency of that discharge. Now both of the batteries here have a rating of C20 equals 105 amp hours. Now breaking down this equation here, C equals the capacity of the battery, the number 20 equals the amount of hours that the battery would be drawn from 100% to 0%, and the 105 amp hours would equal the amount of power drawn from that battery in that time frame. So both of these batteries, if we're 100% and drawn down to 0 in 20 hours, would give us 105 usable amp hours. However, there is a significant difference. If we have a look at the Full River manufacturer's specifications, we can see that that C rating changes depending on the amount of hour discharge. So here we can see that a C100 equals 115 amp hours, a C20 equals 105, C10 95, and C5 86 amp hours. What this means is that as we draw the battery down at a quicker rate of discharge, we're losing the available power we can get from the battery. And this is because as we draw the battery down or draw more amps from the battery, the internal resistance is increased and we lose that capacity output in the form of heat. But when comparing that to the discharge profile of the lithium battery, we can see here that the C5 equals C10, which equals C20, C100, and they all equal 105 amps. This is because there is a lack of internal resistance in the way in which this battery discharges, which means that if we are drawing high-powered appliances off this lithium battery, we're going to get more usable amps than we would from this AGM. This gives us a massive advantage with the lithium battery. Not only are we seeing a much higher usable amp hour rating given that voltage discharge profile, but we can also see the lithium is much more efficient at discharging over a period of time when compared with an AGM battery. These two factors combined to give us a much more efficient and usable power source from the lithium battery in a similar sized and similar rated format. So moving back to the table, I want to talk about another big difference between these two units, and that's the cycle life, or the longevity in which these batteries are going to last. I think again, it's fairly common knowledge that the cycle life of these batteries is severely deteriorated or shortened if you're using high capacities of the battery. So for example, if you draw this battery down to 50 or more percent at a frequent basis, it's going to significantly shorten the cycle life if you compare that to just drawing down 10% before a recharge. Now, I think there is a bit of a misconception with the discharge rates of the lithium batteries. Many people believe that you can just draw these all the way down to 20% each time and it's not going to have any effect on the longevity or that cycle life. However, let's have a look into some of the facts from both of the manufacturers and see whether or not this is the case. So let's start with the AGM battery. Now, having a look at some of the documentation provided by the manufacturer from Full River themselves, we can see a cycle life versus depth of discharge graph. This graph clearly displays that a deeper a battery is discharged, the fewer cycles the battery can complete. The fewer cycles the battery can complete represents a shorter battery life. So let's use a couple of points on this graph to compare it with the lithium battery. So if my AGM battery is depleted continuously by 30% of charge time and time again, then I would expect about 1500 cycles. If I deplete my battery to 50%, then this would shorten to 1000 cycles. And finally, if I really pushed my AGM hard and depleted the battery all the way down to a 20% state of charge, then I would only expect 600 cycles. Now, the manufacturer clearly illustrates here that the further we discharge this battery, the less life we're going to get from it. And this is because as we discharge the battery, we create sulfates within the cells. Now, between the time the battery is discharged and recharged, again, The sulfates harden and crystallize along the cell walls, and this prevents a full charge and therefore over time reduces the efficiency and the capacity of the battery. Now moving on to the lithium battery. Now although iTechWorld don't provide a visual graph view of the cycle life versus depths of discharge, they still provide key data. The 120X is quoted to be able to complete 8,000 cycles if discharged by 30%, 5,000 cycles if discharged by 50%, and 2,000 cycles if discharged by 80%. Now if we compare the differences in cycle life at those ratings, we can see we end up with a huge difference between the lithium and the AGM. We're getting 355% more cycle life from the lithium than we do for the AGM counterpart. Now it should be noted that realistically the AGM battery won't be discharged by 80% time and time again. So if we remove that outlier and just use the 50 and 20% ratings, we can see here that brings us to a change or difference between these batteries of 400%, representing this battery here lasting 4 times longer theoretically than this AGM. I think this also clarifies some misconceptions people have with the discharge rates on lithium batteries. Many people believe that we can discharge this all the way down to empty time and time again without any effect on the longevity of the battery. However, iTechWorld here provides their own data which suggests otherwise. If we discharge this battery all the way down to empty time and time again, comparing that with when only using a small amount of the battery capacity, we can see here a significant difference in the longevity or the cycle life of this unit. But saying that overall doesn't matter whether or not you're using an AGM or a conventional battery or the lithium battery, we can see here that the data proves that if you want to get the maximum cycle life or the longevity out of either of these units, the best method is to keep them topped up at all times or as much as you possibly can. Moving on to another difference between these two units, and that is the power input and output ratings for both of these batteries. So we can see here the iTechWorld specifies some discharge rates for their 120X, and we can see it's clearly specified that we can run 270 amps of discharge for 5 seconds, 175 amps for 5 minutes, and 150 amps for continuous. Now, although the AGM manufacturer Full River don't specify discharge rates on their battery here, from the knowledge we have regarding AGM batteries, a reasonable discharge rate would be a maximum of 40 to 50 amps, and that's really pushing it. And this brings us back to the voltage discharge profile that we've talked about before. If we were to draw 40 to 50 amps from this AGM batteries, it's going to immediately draw that voltage right down to 12 or below 12 volt, and therefore again we're going to create that internal resistance and lose the efficiency in heat. Although drawing a high rate of discharge from an AGM battery might be technically possible, it's just not going to be a realistic or viable option in your four-wheel drive. And the lithium battery here, as we can see, can discharge huge amounts of current for extended periods of times and even further amounts of current for short intervals. This is going to provide a huge advantage to the lithium battery, again, over the AGM. This brings us to the way in which we can charge these batteries here, and they both have very specific regulations or requirements in which they can be charged to maximize the efficiency and the longevity from both units. Now, batteries generally have 3 stages. They have a bulk mode, an absorption mode, and a float mode, and they require different voltages at this stage depending on their chemical makeup. So going back to the specifications supplied by Full River, we can see here that they're specifying 14.7, 14.7 and 13.6 volts of input coming in at each of those stages to optimize the efficiency and longevity of this particular unit. Now, in order to manage this in our four-wheel drive applications, we need to administer those voltages through a battery charger or a battery management system in order to provide the best result from this battery. So in the case of my Land Cruiser 200 series, I'm using a REDARC BC-DC 1240D. Now this is a 12 volt charger that can provide a maximum of 40 amps of charge into an auxiliary battery introduced. This system has 4 charging profiles being A, B, C and Li, and each of these profiles have specific voltages set up for different types of units to most efficiently charge that type of battery. So going across to the REDARC specifications and having a look at how these profiles work, we can see that the REDARC system has a maximum voltage of 14.6 and a float voltage of 13.3. Now comparing that with the Full River specifications, we can see that this very closely matches the requirements and is the best profile to use for the AGM battery. So moving here onto the 120X, we can see that iTechWorld specify their own optimal battery voltages, and this is going to be 14.4 volts at bulk and absorption and 13.5 volts at float. So moving back to those REDARC specifications and having a look at the charging profiles, we can see here that the profile marked Li, which does stand for lithium, has a maximum voltage of 14.5 and a float voltage of 13.6. This is obviously going to be the best profile for our lithium battery, and later on in the video I'll show you how to change that red arc system over to that charging profile. Now, iTechWorld sometimes do also advertise this lithium battery as a drop-in replacement for your auxiliary battery with no changes required, and although this is somewhat true, there are some things you have to be aware of. Now, having a look at the user manual documentation that comes with the 120X, we can clearly see that we're not allowed to put more than 15 volt into this battery, and the BMS is going to recognise that and shut it down if we do so. Now, having a look at the red arc profiles, we can see that profile A very closely matches that of profile LI, and to be honest, there's nothing stopping us using profile A. However, profiles B and C are using 15 and 15.3 volts respectively as their maximum voltage, and this therefore isn't going to be compatible with the 120X. So this is something you do have to be mindful, regardless of whether you're using a red arc charging system or any other brand. Make sure you know what charging profile it's been set to and the maximum voltages that it's going to be reaching. And if need be, change that profile across. So this brings us to perhaps one of the biggest issues with lithium batteries, and that is the lack of ability to deal with high temperatures. Now, I think it's fairly publicised that a lot of people suggest that lithium batteries can't cope with high heat and it significantly reduces their cycle life. So let's have a look at this and see if we can find out some more information. So I want to start by having a look at some of the temperature ranges that iTechWorld specify for this battery. So let's jump over to the 120X's specification sheet and see what we can see. First up, we can see that the optimal range is between 5 and 60 degrees Celsius, and the battery management system has a range between -40 and 80 degrees Celsius. We can also note that there's a safety protection isolator at 80 degrees, which would indicate that the BMS in here will protect the cells within the battery when they get too hot, whether that be by reducing its efficiency and its power output or by shutting it off completely. Many people are going to say that this battery is not suited for under bonnet use because it's going to get hotter than 80 degrees under there, and therefore it's going to shut down and not work. Now look, I do agree that the engine bay will probably get hotter than 80 degrees, particularly at low range four-wheel driving, reduced airflow in a hot environment. However, I'm unsure as to whether or not the battery itself or the internal components within the battery are going to get to that 80 degree mark. The fact that iTechWorld also provides warranty claims for under bonnet use would suggest that they have faith in the battery to work in that environment. Now, in addition to this, I also went out and checked some of the temperature operating ranges of some other equipment that I use within the engine bay of my 200 series Land Cruiser. So starting with the red arc BC-DC battery charger that we spoke about earlier, and this has an operating temperature range of between -15 and also 80 degrees Celsius. Now, I understand and I will concede that that battery charger is mounted at the front of the engine bay near the front grille, and that's in order to collect that airflow even during slow speeds in order to stay cool and remain at an efficient temperature. However, in my GU Patrol that I owned previously and lived in the Kimberley region of Western Australia for 2 years with, it was mounted in the most upper top rear corner of the engine bay, exposed to all that heat, and it still worked without any issues. Secondly, I also wanted to have a look at the operating temperatures specified by a Full River for the AGM batteries. There's no doubt that the AGM battery is also going to be affected by heat, and I'm sure as that temperature gets hotter, the battery efficiency is going to decrease. So jumping over to the Full River documents, we can see here that it's got an operating range between -40 and 71 degrees. Now, correct me if I'm wrong, but the manufacturer is saying that this shouldn't be used in temperatures over 71 degrees Celsius. Yet I've been using it for the last 3 years in my Land Cruiser 200 series and 2 years in the Prado 150 series before that, and both of these systems are still performing well and have never had any significant issues that we've determined to be caused by heat. It's for these reasons that I believe that this lithium battery is going to work just fine in an underbody application, and I still think it's going to exceed by the capabilities of this AGM. The last thing I want to talk about is price, but more specifically, the value for money for buying a lithium compared to that of an AGM. So starting with this Full River AGM, which is a reputable company with a good quality backing, you're looking at about $450 to $460 here in Australia in store. So it's still a hefty investment for any system. Now, this lithium battery that I've picked up here from iTechWorld came in at $910, but that was delivered to my place in regional Western Australia. So look, it is expensive. It's twice the price of the AGM battery. However, it has got some significant benefits. Now, in addition to that, $910 for this battery is not the regular retail price. I did have to wait until some specials were on. However, if you are looking at buying some of these batteries, they do seem to have some pretty good specials on an ongoing basis. So if you've got some time, wait it out and see what you can pick up. Now, we have mentioned today that we are looking at a significant benefit with this battery here, not only disregarding voltage discharge rates and the discharge we can bring from these batteries, but this is a 105 amp hour battery and this is a 120 amp hour. In addition to that, we do have those more usable amps, with this battery providing almost twice as many as the AGM, and we have that huge weight savings of 20 kilos over the front axles, which provides a significant benefit. So yes, you're paying a lot more, but you're getting a lot out of it as well. Now perhaps you're thinking, well, the AGM's doing just fine in your setup and you just don't need those usable amp hours that comes with the lithium or the high discharge rates that you get with it as well, and the AGM's still going to come in cheaper, right? But remember, we did talk about cycle life before, and this lithium battery has a significantly longer cycle life given controlled environment. So before, we talked about how this battery will last up to 4 times as long as an AGM. Now, if you're using it in a 4-wheel drive application, you have to replace this battery 4 times for every once of this. Well, I think it's clear to see the financial benefit there. Given that those tests are theoretical, you could reduce the stats on this and bring it right down to say 50%, but you're still looking at a battery like this lasting twice as long as an AGM like this. Financially, it's going to work out to be the same anyway, but you're getting a lot more benefit from a lithium like this one. Now, I should mention that I specifically bought the iTechWorld 120X because of its value for money. It comes in at less than 50% of some of the other high name brands on the Australian market, and I really do believe if it holds up like it says it does, it's going to be worth that value. And this is something I'm going to be putting to the test over the next few years. I'm going to be reviewing and reporting back regularly as to how I found this battery and how it's holding up with the conditions I put it through. Now, we've spoken at length now about some of the similarities and differences between these two different battery types, and theoretically on paper, the lithium battery is sure looking the goods, but it's now time to get it ready for installation into the Land Cruiser. I'm going to take you along and show you what's included and what's needed to do so, and we'll see how it all looks when it's all fitted up. So let's get onto that. Even though I think the battery will be fine under bonnet in the Land Cruiser, it won't stop me from putting in some measures to reduce the internal temperatures. I'm going to wrap the bottom and the sides of the battery in an adhesive foam and foil packed insulator, which will attempt to reduce some of the heat transfer between the engine bay and the battery. Once this is complete, it is time to prepare the mounting area. There is a plastic battery tray that needs to be modified for the new battery. As we can see here, the full river battery fits perfectly into this tray. However, placing the lithium on top, we can see that it's too long. There is a very easy fix, just using a sharp knife to trim the soft plastic edges to create a flat tray. This is a good time to quickly talk about the physical dimensions of the battery. I'll put the official dimensions up on the screen, but in summary, we can observe that the 120X is a few mil deeper, about 20 millimeters longer, and about 10 millimeters higher than the full river. Although not significant, if your battery is already tight, this may struggle to fit, particularly if you are wrapping it in a heat insulating material like I am. Time to put the battery tray back into the Cruiser and fit the new battery. Given I've added that little material around the battery, it fits perfectly into the space of the Land Cruiser 200 series. Now that 10 millimeters in extra height has transferred into the bracket, and this requires some persuasion to correct. Nothing some heat and a hammer can't fix. With the bracket lining up, it's time to tighten the mounting hardware down and secure the battery. Before we connect the terminals and provide some charge to the battery, we need to change the charging profile on the red arc battery charger. Taking the front plastic engine shroud off, loosening and pulling forward the front grille to provide some room, it's a matter of finding the wiring coming from the rear of the BC-DC charger. There is an array of wiring here, however we are specifically looking for a small gauge green and orange wire. Connecting these two as I'm testing here will let the charger know to use the profile LI. Quickly checking the flashing light on the charger, and we are ready to continue. Bolting down both the positive and negative terminals using the M8 bolts, and this is where I appreciate the wiring completed by Ultimate 4-wheel drive equipment. There is no messy wiring coming from the terminals, and the system is neat and tidy. I've added a little charge to the primary starting battery and waited for the red arc to notice and provide charge to confirm the correct charging profile and the correct voltage going to the new lithium battery. The plastics are refitted and we're almost there. So we are almost done, but there's one more thing left to do, and that is to set up a way to monitor our state of charge with this new lithium battery. As we mentioned earlier, an AGM battery or a conventional battery works on a voltage discharge profile. If your voltage is around 12.9, you know you've got a high state of charge, but as it starts to drop, you can see that state of charge come down. Whereas the lithium battery, like mentioned before, holds that voltage discharge even when high amps are being drawn from the battery. So therefore, we've got to find another way to measure or to view the state of charge. And that's where a little device like this comes in handy, which is the Victron BMV712 battery monitor. This little device is smart enough to show us a whole range of data, including the state of charge regardless of the voltage when set up correctly. Now the great thing about iTechWorld is that on their website they have a document giving you all the settings required for numerous different types of battery monitors, including the Victron BMV712. So let's jump into the phone settings and I'll show you how to set it up. So this is where we're going to be changing a few settings. We go into our Victron Connect app, wait for it to load up, and then we go into our settings. Once we're in our settings, we go to our battery settings, and you can see here it is set up for an AGM discharge profile. So starting with the battery capacity, we're going to be changing that to 120 amps. Moving down to our charged voltage, this is going to be 13.5 volt. Our discharge floor is going to be all the way down to 12%. So you can see there how much extra capacity we're getting out of this lithium battery. Our tail current is going to be 2%. And moving down, our charge detection time will remain at 3. We're going to be moving our exponent down to 1.05. Our charge efficiency factor is going to move up to 99%. And the rest will stay the same. We now have a Victron battery monitor set up for a lithium battery. So there we have it. It really is as simple as that. A few quick settings adjusted on there made it very easy by that document from iTechWorld, and now we have a way to view our state of charge and all the data in relation to our auxiliary battery. There we have it. The lithium battery is installed under bonnet and we're ready to start testing to see whether or not it has what it takes to stand up to some of the conditions I put it through and hopefully our big lap around Australia. Like I said earlier, there are plenty of dual battery systems to choose from and plenty of lithium batteries to choose from as well. I chose this particular battery as a value for money and cost-effective solution. I'm going to see whether it holds up over the course of time. Obviously, any results I get, good or bad, are going to be reported back on the channel, so make sure you keep in touch and see how we're going. There we have it, guys. I hope you were able to get some value from this video, learn something new about lithium, and perhaps I was able to debunk or at least clarify some of the points surrounding lithium batteries, and in particular under bonnet applications. So guys, if you wanted to pick up one of these iTechWorld batteries for yourself, I don't have any of the discount codes because I'm not sponsored. However, iTechWorld do seem to run a lot of promotions and deals on an ongoing basis, so keep an eye out for them for the best possible price. However, be prepared, you're going to get a lot of advertising email from iTechWorld. They really need to lay off those subscriptions. But guys, I hope you enjoyed the video and I hope to see you in the next episode. Cheers.